We're going to do today problems about substitution, and these are questions from my students, so I love that they're doing that. And so thank you. First of all, we're gonna say this is a chapter of substitution and elimination reactions. But here we're gonna be talking first about substitution. In another video, we'll do elimination. So substitution problem in here on alkyl halides. And we're also, so principally that. What is the strategy to solve this problem? So the first problem I got is about identifying reagents. Identifying reagents. And here I'm gonna do a list of reagents, and then I'm gonna give you the reactions that we're gonna be working on. So reagent A is HBr, hydrobromic acid. Reagent B is hydroxide. Reagent C is hydrochloric acid. Reagent D is tosyl chloride and pyridine. Reagent E is cyanide. Reagent F is, see, this is the conjugate base of dihydrogen sulfide. So similar to that, right? But there is a difference in nucleophilicity. So now reagent G is acetate. There's two ways of writing acetate. Let's say that we do that, but you often see it this way. So this is just an abbreviation. But I'm going to put the negative charge where it belongs, in the oxygen. And we have reagent H, which is water. And reagent I know it's a long list, but we're going to choose from those. So dihydrogen sulfide. So now let's work on one reaction and try to identify the reagents that I need to choose to accomplish the transformation. So problem one, I have the following reaction. This is OTS, this is tosyl, and this, we need to figure out what goes there, right? What reagent. This is my product, an alcohol. So notice here first, let's see what the transformation was. This is a substitution reaction. We're changing the tosyl by an OH. Second, we want to see what kind of substrate is that. This is my alpha carbon, and this is primary, and that's a primary alcohol. So this reaction, because it's primary, is likely to go by an SN2. So it's substitution, nucleophilic, order 2 kinetics. For that, we need a strong nucleophile. Also, analyzing the reagent here, we have a good leaving group. Tosylate is an excellent leaving group. So having said all that, this reaction will proceed under SN2 condition. SN2 reactions proceed best with strong nucleophiles. Generally, reagents that are strong nucleophiles are also strong bases. So we say strong base, strong nucleophile. Since we are introducing an OH, here there's a hydroxyl group, then the reagent that we need to use, strong base, strong nucleophile, is hydroxide. And this is reagent B. So now I'm going to erase this. And what I need here is OH. So the answer to this problem is reagent B. B here. Okay, that's my first reaction. Let's go over to another one. I'm going to use another color for that one. That's my problem too, but I'm going to be using the same list of reagents. Now the problem is the following. I have an alcohol, that's propanol, and I need to figure out what reagent I need to use to synthesize this nitrile, right? So we call nitriles the organic molecules that contain a cyano group. Right, so first analyzing the structure, that is a primary alcohol, 1, 2, 3 carbons, that's propanol, and propane nitrile is this. And so we need to remove the OH and substitute it by the cyano group. What do we use for that? But first, is primary. Okay, this is a substitution. Primary substrates react best by SN2 mechanism. So the mechanism is going to be SN2, but we know this is a terrible leaving group. So being a bad leaving group, we need to make it better. The way we're going to make this better is we're going to select a reagent here that's going to transform that into a better leaving group. That reagent here is D-tosyl chloride and pyridine. That way, I'm going to use here D-tosyl chloride and pyridine, and I am going to make now this, I'm making this a better leaving group. Now that's excellent. Now I can do my SN2 reaction. And what would be the nucleophile? Well, the nucleophile here, I'm looking in my chart, cyanide. So what I'm going to do now, I'm going to write my nucleophile over here, and you're going to have the attack on the alpha carbon, and at the same time, loss of leaving group. And that way, you get the product here, the propane nitrile. So bottom line, we needed 2 reagents. First, we needed to make a better leaving group, so we use reagent D here. And so let's write that down. I have used D, and D is tosyl chloride and pyridine. And then I use cyanide, so that is reagent E. So a sequence of 2 reagents I need to use for that problem, okay? Now, let's do a couple more, but I'm still keeping the same list of reagents. So I'm going to erase this. Let's work on another. So notice that we're analyzing, since we have reagents here, now we're going to be analyzing the substrate. And what is the chemical change that we're doing in substitution for what? What is that we're changing? So let's do something else. So, and the substrate that we had so far in these 2 examples are primary. And they are proceeding by SN2 mechanism. Knowing reaction mechanism help us, knowing structure help us predict products, which is the ultimate goal when you're solving these problems in organic chemistry. So let's do one reaction here. This I'm going to say is number 3. No, now let's do better. I'm going to do this too in the next video.